Hey guys, so the first section of chapter 2 here, we're going to work with inequalities. We're just going to work with simple inequalities and solve them with just one variable. Okay, so we got to talk about these properties real quick. The first two are best understood by using a number line, and then the third one is a really important property that basically the one thing that makes an inequality different from solving an equation. Okay, so to start, we've got this transitive property. Okay, the easiest way to understand the transitive property is to just graph it on a number line. Okay, so if A is less than B, remember that smaller numbers are on the left, bigger numbers are on the right for a number line. So A is, let's say, right there, and B is right here, right? So A is less than B. And B is less than C, so that means that C has to be to the right of B, then A has to be less than C. Okay, there's no possible way to draw this scenario where A is less than B and B is less than C, where also A would not be less than C. Okay, so that's the transitive property. All right, the addition property, if we've got A is less than B, okay, so let's just start here, A is less than B, and we add C to both of those, all right, so the same number, let's say C, just as like right here, okay, so C moves us there, and C moves us there. All right, so if you add C, some same number, to both A and B, B is still going to be to the right or bigger than A. Okay, and the last one, the multiplication property. Okay, so the multiplication property, remember, is the same as for dividing, because dividing is the same as multiplying by the inverse of a number. Right? Basically, if you multiply or divide by a positive number, nothing changes, just the same thing. Okay, so 1 is pretty easy. The second one is the real important one. Okay, so if you're multiplying or dividing by a negative number, then you have to flip the sign. Okay, so if you multiply or divide by a negative number when trying to solve an inequality, you flip the sign. That's pretty much the biggest part of solving an inequality. Okay, so we're just going to do a couple examples. I say couple, I meant lot of examples of how to do this. We're going to solve each one and graph on a number line. Okay, so we just solve this like you'd normally solve a regular equation. The only thing you need to remember is that you're going to flip the sign if you multiply or divide by a negative number. Okay, so we'll start by subtracting the 16. So 3x is less than negative 9. And divide by 3. So x, oh, that's just awful. Okay, x is less than negative 3. That's the answer. And to graph it, all right, what I suggest is you always just put 0 in the middle, and then you can just put whatever number is important, so negative 3 can go on here. Remember that in order to graph this, it's an open circle if it's just less than or greater than, and it's a closed circle if it's less than or equal to or greater than or equal to. So open circle. Less than means to the left, and so that is the answer right there. Okay, both the graph and that inequality mean the exact same thing. All right, number 2. We will subtract the 11 over to start, so negative 3 halves r is greater than negative 15. And to get rid of the negative 3 halves, we're going to have to multiply by the inverse of that, or the reciprocal. So we're going to multiply both sides by negative 2/3. Okay, so you can multiply both sides by negative 2/3. Okay, so these would cancel each other out. R is going to be less than, remember we multiplied by a negative number, which means you have to flip the sign. Multiply this out, okay, you can just cross cancel. This becomes 5, this becomes 1, and you're going to get negative times a negative. It's a positive, so r is less than 10. All right, once again, to graph it, we'll put 0 on there, we'll put 10 on there, open circle, r is less than, so shade to the left. Looks just like that. And number 3, all right, we're going to have to distribute both here. Remember the distributive property. Distribute the 3, distribute the 2. We're going to get 12z minus 3 is greater than 12z minus 10. Okay, we get all the z's to one side, all the numbers to one side, so we'll subtract 12z over our 12z's, cancel each other out, we're just left with 0. Add the 3 to the right side, and we get negative 7. So 0 is greater than negative 7. Now, if you get to a point like this, okay, where your variables cancel each other out, all right, so notice how our z's canceled each other out when we subtracted over. All right, once you get to that, you look at this statement just with numbers. 0 is greater than -7. You ask yourself, is that true? If it is true, the answer is all real numbers. If the answer is not true, then the answer is no solution. So here, the answer is true, so all reals. And to graph it, you would just have a number line with the whole thing shaded. Okay? And number 4, up top. Okay, when you distribute this whole -2, don't forget to bring the negative with the 2 when you're distributing. Okay, so we have 3 minus 2q plus 2 is less than 5. Okay, we've got the q by itself already, so we can combine our 3 and our 2. We just got -2q plus 5 is less than 5. Subtract the 5 over, -2q is less than 0. Divide by -2, and we get q is greater than 0. Why did I change the sign? Because I divided by a -2. Remember, if you divide by a negative number, you have to flip the sign. So to graph it, put the 0 on there, shade to the right because we're greater, and you need an open circle at 0 because it's greater than. All right, and the last one on this page. All right, when you distribute this negative, so we have -10 plus r is less than r minus 15. We'll pull all the r's to the left. They'll cancel each other out, left with 0. Push the numbers to the right, so add the 10 to get -5. We have 0 is less than -5. Remember, at this point, whenever your variables cancel out, you ask yourself, is this a true statement? Right? Is 0 less than -5? No, that doesn't make any sense, so the answer is going to be no solution. Okay, another symbol I might use for no solution is that one right there. It's called the null set. And obviously to graph that, it's just an empty number line. Okay, so take one last quick look at number 3 and number 5 to see the difference between all solutions and no solutions. And we'll do some more examples on the back. Okay, so in number 6 here, we're going to get all the k's to the left, numbers to the right. Okay, so we'll add a 4/5 k. So we've got 4/5 k plus 4/5 k is going to be 8/5 k. Add the 8 to the other side, to the right, and we'll have 16. Now to get k by itself, we need to multiply both sides by the reciprocal. Multiply both sides by 5/8. Okay, so these cancel each other out. We're left with k. Keep it greater because we're multiplying by a positive number. It's not negative. We can cross cancel the 16 and the 8, and we're left with 10. So k is greater than 10. Put our 0, put our 10, open circle, greater than. Nice, easy problem. And number 7. Okay, then the 1/2 a is by itself, the -1/2 a, so we'll just add the 19 over, leave the -1/2 a. It's greater than, add the 19 over, so we'll have 4. Then we need to multiply by -2 to get a by itself. So these will cancel each other out. We're left with a. Flip the sign because we multiplied by a negative number, and -8. So a is less than -8. Put my 0, -8, open circle, less than. Okay, number 8 up here. We need to basically distribute the negative again. Okay, we distribute that negative, we'll have 8 minus 2b plus 3 is less than 2b minus 3. Okay, I tend to always get my my variables to the left and numbers to the right, so I just do that by habit. If you want to go the other way, you obviously are more than welcome to do that. So I'll have -4b over here, and I'm going to subtract 11 to the other side to have -14. Divide by -4. So I need to flip the sign, and 14 over 4 reduces to 7/2. Okay, so for this one, I've got my 0, put my 7/2 on there, open circle, greater than, and you're all set. Number 9. These are a little bit repetitive, but just trying to go over some algebra stuff. That's why I'm doing so many examples here. Just a little review. Distribute a negative again. Remember, if you notice, I'm doing a lot of problems where you have to distribute a negative or a -2 or whatever. Just to remember to do that and not to just enact that negative on the 7. Okay, so we have p minus 7 plus p is greater than 2p plus 1. We can do an extra step and combine the like terms so we can see it a little bit better. If you don't need to do that, like I did up in 8, that's totally fine. Get all the p's to the left, they cancel each other out, left with 0, add the 7 to the right. 0 is greater than 8, is it true? It's not true. The answer is no solution, or the empty set. And if you had to graph it, you would just leave the empty set just like that. Alright, 10 and 11, our last two problems are a little bit bigger, a little bit different. One's got decimals, one's got multiple parentheses. So for number 10, remember we have to distribute the whole -2. Like I said, I was reviewing that quite a bit so we don't forget it, and then distribute the negative on the right side. So we have 5 plus 2z plus 8 is greater than z plus z plus 1. Alright, let's combine our like terms. On both sides, 2z plus 13 is greater than 2z plus 1. When you get all of our z's to the left, they're going to cancel each other out. We'll subtract 13 over. 0 is greater than -12. That one is a true statement, so the answer is all solutions. And remember to graph it. It would be everything, but the graph is pretty much meaningless at that point. Alright, and the last problem here, we'll work a little bit with decimals. We'll distribute this 2.7 and the 7.2. So we have 2.7 times 3. I should be able to do that in my head, but I'm going to use a calculator just so I don't mess it up. 8.1 v minus 2.7 times 8, which is 21.6. It's greater than 7.2 times 8v, which is 57.6v minus 7.2 times 3, 21.6. Should have been able to do that in my head. And great. Okay, we're all set. Let's get our v's to either way. I just like to read my variables first, especially with inequalities, because I mess it up on the variables on the right. So I'm going to pull my variables to the left, so I need to do 8.1 minus 57.6. Get negative 49.5v. Add the 21.6 over, and they're going to cancel out, so it's going to be 0. So negative 49.5v is greater than 0. When you divide by negative 49.5v, or divide by negative 49.5, that's a lot of syllables in that freaking number. Okay, oh, that's not going to happen. When you do divide by the negative there, we're going to flip the sign. So v is less than 0. Okay, so the answer is v is less than 0. Put my 0 in there, open circle, less than, and all finished. That's the first lesson.